Okay, so this is problem 3 from lesson 2.7, and 2.7 is all about special patterns. We're supposed to factor here, so the directions are to factor. But one of the special patterns that came up in 2.7 was something called the difference of two squares, and it's a pattern you really need to recognize. It shows up a lot, and it makes your life a lot easier if you know that pattern. So what is that pattern? It's a perfect square minus another perfect square. It's called the difference of two squares. Something to the second power minus something else to the second power. If you recognize that pattern, you do not have to take the time to set up an area model. You can immediately go to the factor, which is the multiplication problem, the two binomials. Whatever is being squared here, whatever is being squared here, those numbers are a and b. It's a plus pattern, and it's a minus pattern. Okay, so here it is with this problem. We have something to the second power. This one is easy to see. This is m squared. So my first thing being squared, my a value, so to speak, is actually a variable m here. Now this one is not being raised to the second power, but it is a perfect square. If you recognize that, just get my calculator here. If you recognize that, you can jump right to what this thing is squared. But if not, use a calculator. The square root feature, so the square root button, will tell you if that is a number that can be raised to the second power. It is. It's 7. As opposed to like if it was 50, right? If I did the square root of 50, it's not going to be a perfect square. But 49 is. 49 is 7 squared. So I can rewrite this guy as 7 to the second power, which is really helpful for identifying this pattern because I have something to the second power minus something to the second power. I do not need to set up an area model to factor here. I can go immediately to m plus 7 because it's whatever's being squared here, whatever's being squared there. It's a plus minus pattern. M minus 7. And that is it. That gets me this value. I can prove it here. I'll prove it a couple different ways. I'll actually do an area model where I multiply my answer. Look, I'll do m plus 7 and m minus 7. M times m squared, m times 7, 7m, m times a negative 7, minus 7m, 7 times a negative 7, negative 49. Put all these pieces together, m squared plus 7m plus a negative 7m minus 49. These cancel, and I got back where I started. Now, to be clear, my final answer is this. This I was supposed to factor, right? So this is my final answer. I'm just proving that if I did multiply these out, I get back where I started, m squared minus 49. Okay, so hopefully you would do this problem very quickly. You'd recognize the pattern, you'd figure it out, you'd have it factored. If, however, and I'll show you this, you did not recognize the pattern, you can use your standard form, your standard practices that we've talked about for factoring. So I could factor this, that's the directions, by setting up an area model and using my diamond problem. M squared goes here. I get a minus 49 there. All right, set up my diamond problem. So here's a little bit of a trick with these though. There is no m piece. There's m squared and then there's just your number. So these two pieces have to add up to 0 because that piece doesn't exist in the original problem. But they have to have this multiplier, m squared times a negative 49, so negative 49 m squared. So I need two numbers that will add to 0, meaning they have to be opposites, and multiply together to be a negative 49 m squared. And the only way to do that is with 7 and 7. 7 times 7 is negative 49, and if I make one of them negative, they'll multiply together to be a negative, then they'll add to be 0. So these are the numbers that I get to plug into my area model. 7m minus 7m. Because I got the m squared, right? I got m and m, 7 minus 7. To put them together in my binomials, because I'm asked to factor, m plus 7 and minus 7. So my factored response, whether I use the shortcut or the area model, is the same answer, m plus 7 times m minus 7. Here it is up here if I recognize the pattern, m plus 7 times m minus 7. Hope that's helpful. Email me anytime with questions.